All right, let's finish off the day with one more lecture. Everybody hang in there. It's going to be over before you know it, but this is important stuff, and it is the time that we all agreed to meet. So, and if people left, hey, that's their choice. Everybody has a choice to do whatever they'd like. In the end, they have to accept the consequences of those choices. All right. So now we're going to talk about consumer equilibrium. We're going to talk about what all this stuff has led to, right? Like we've established the nature of like how we model preferences. We've established the nature of like how we model the constraints on those preferences. And now we want to interact the two to get us to the optimal consumption bundle that the model is meant to get us to. So the objective of the consumer is to choose a consumption bundle that maximizes his or her utility or satisfaction. If there was no scarcity, the more is better property would imply that consumers would want to consume bundles that contain an infinite amount of both goods. However, one implication of scarcity is that the consumer must select a bundle that lies inside the budget set that is an affordable consumption bundle. Right, so the consumer is limited to what the affordable set is based on what prices and income is. So we now combine our theory of consumer preferences with our analysis of constraints to see how we model the way a consumer goes about selecting the best affordable bundle. So consider a consumption bundle such as A, right? So A is on the budget line and therefore it is affordable. It's also on an indifference curve, right? The indifference curve is pretty high up, so it represents a consumption bundle that yields a good amount of utility. The bundle of goods X and Y lies on the budget line as mentioned, so the cost completely exhausts the consumer's income. The objective of the consumer, though, is to choose a consumption bundle that maximizes his or her utility or satisfaction. So then the question is, can the consumer do better than this? What do you think? Yeah, right. The consumer can do better than this because, as we know, there's an infinite amount of indifference curves here, right? We don't see them all, but they're there. So given the income and prices corresponding to the budget line, can the consumer do better? That is, can the consumer achieve a higher indifference curve? The answer is, of course, yes. So here's another indifference curve. Obviously, this one is further away from the origin, so it corresponds to combinations of the two goods that yield a higher level of overall utility. So consumption bundle B exhausts all of the consumer's income and is preferred to consumption bundle A. So it's inefficient for the consumer to consume bundle A because bundle B both is affordable and yields a higher level of well-being or utility. But is bundle B optimal? Do you think it is the optimal consumption bundle? No, it is not, right? There are higher indifference curves that the consumer can consume on. So bundle B exhausts the consumer's budget, but there's another affordable bundle that's even better, and that is consumption bundle C. Consumption bundle C lies on the budget set, exhausts the consumer's income, and lies on the highest possible indifference curve. This indifference curve is just tangent, it's just touching the budget constraint, meaning that the consumption bundle on that curve is the best the consumer can do as far as like satisfaction, given her income and the prices that she faces. So note that there's other bundles such as D, let's say, that the consumer does prefer more than C, but obviously that's not an affordable bundle. So we say that C represents the consumer's equilibrium choice. It is the consumer equilibrium. It is the combination of the two goods that the consumer prefers the most and is most affordable. So the consumer equilibrium is the equilibrium consumption bundle that is affordable and yields the greatest utility to the consumer. An important property of the consumer equilibrium is that at the equilibrium consumption bundle, the slope of the indifference curve is exactly equal to the slope of the budget line. So at that point there, the market rate of substitution, the rate at which the market expects one to trade off one good for another is exactly equal to the subjective rate of substitution, what we call the marginal rate of substitution, right? That reflects the subjective rate that the consumer is willing to trade off one good for the other in order to remain as happy as possible. So at that point there, the marginal rate of substitution is exactly equal to the market rate of substitution. So we've got marginal rate of substitution equal to the ratio of the price of X to the price of Y. Recall that the marginal rate of substitution is itself equal to the ratio of the marginal utility of good X to the marginal utility of good Y from what we derived earlier. And that is the marginal rate of substitution. Thus, one can gain more insight into the consumer equilibrium by considering that at the equilibrium, the marginal rate of substitution, the ratio of the marginal utility of X to the marginal utility of Y, is equal to the market rate of substitution, the ratio of the price of X to the price of Y. So we can move some things around here to get to an expression that provides like more intuition about the nature of this equilibrium. So let's say we were to multiply both sides by the marginal utility of Y to get that on the right-hand side, and then we divide both sides by the price of X to get that on the left-hand side, and that gets us to this expression here. So what this expression is telling us is that the marginal utility per dollar spent on good X at the equilibrium is equal to the marginal utility per dollar spent on good Y at the equilibrium. So if the consumer at the equilibrium has $1 and is trying to figure out what to spend that dollar on, she is going to be indifferent between spending it on either X or Y because both of them at that point make her as happy in terms of marginal utility. So the amount of utility per dollar spent on each good is equivalent. So for example, at point A, the slope of the indifference curve we see is steeper in absolute value than the market rate of substitution. So essentially, the rate at which the consumer is willing to trade off good X for Y is greater than the rate at which he's expected to trade it off based on what the market is setting in terms of prices. So she values an additional unit of good X more at this point than the market does, and therefore it makes sense for her to consume more of X and less of Y. So she would move along her budget line away from A. Also, at point A, another way to say the same thing that I just said is to say that the marginal rate of substitution is greater than the market rate of substitution. So this expression holds there. Again, moving things around, it's telling us that the marginal utility per dollar spent on good X is greater here than it is for the marginal utility of good Y. So therefore, if she were to spend $1 on good X at this point, she would get a greater amount of extra utility than spending $1 on good Y at that point. And therefore, it makes sense to consume more of X and less of Y. But given that we know that the consumption of any good exhibits diminishing marginal utility, then as she consumes more of X, each additional unit provides less satisfaction than the prior one, which eventually gets this to be equivalent, right? As she consumes more and more X, then this marginal utility will diminish to the point where eventually it will be equal to that. And that'll get us to the equilibrium, and that means that at the equilibrium, the marginal utility per dollar spent across all goods is equivalent. And the consumer is as happy as she possibly can be. So this means the consumer is willing to give up more of good Y to get an additional unit of X. Over here at point A, as I said, as this occurs, each successive unit of X is worth less in utility due to diminishing marginal utility, eventually bringing the consumer to point C, where we're back at the point where the marginal utility per dollar spent is equivalent across all goods, as I said. All right, so that's the rational consumer choice model. That's the preferences. That's the budget constraint. That's the interaction of the two that gets us to an equilibrium. That's what equilibrium represents. That's why it is an equilibrium. That's why if the model is anywhere else but that point of equilibrium, it will drive the point of consumption to that equilibrium because that is the best the consumer can do, and that is what we want to model. So therefore, it's been achieved what we tried to set out with setting all this stuff up. We can now say that this model can help us to understand how people choose their optimal consumption bundle via this entire framework. It explains it. It works. All right, now let's do comparative statics. Consider what happens when prices change or income changes and how that affects the equilibrium, right? We talked about how prices and income affect the budget line, right? So we're going to see the same effects here, and then we're going to look at how that affects the equilibrium choice. So here is our optimal consumption bundle. So we know that a change in the price of a good will lead to a change in the equilibrium consumption bundle because the budget line will shift and the market rate of substitution will change, which means that we'll no longer be at a point where the market rate of substitution is equal to the marginal rate of substitution. And so the marginal utility per dollar spent on one good will not be equivalent across all goods, and the consumer will want to move away from that equilibrium to another consumption bundle. So recall that the reduction in the price of good X leads to, so this is going to go down, right? So what's going to happen to this point here? It's going to move out, right? There's going to be more of the good X that can be purchased when the price of good X goes down. So this leads to a counterclockwise rotation of the budget line. So we're initially at this consumer equilibrium. The budget line shifts out. So now we're here. Obviously, that consumption bundle doesn't exhaust the consumer's income, so she's going to want more. She's also on an indifference curve that is not going to give her the highest amount of satisfaction. There are higher indifference curves, right? So she's going to want to do better. So given this new opportunity set, the consumer can achieve a higher level of satisfaction. So going to, again, the consumption bundles that will exhaust her income along the new budget line, the best that she can do is this consumption bundle here. Bundle B represents the most affordable consumption bundle that is most preferred because it lies on the highest indifference curve, corresponding to the highest level of utility. So given a price change, the consumer will move from this consumption bundle to B. In this case, as the price of X went down, she consumed more of X and she consumed less of Y. So precisely where the new equilibrium point lies along the new budget line after a price change depends on the consumer's preferences. It depends on the shape of the indifference curves. So goods X and Y are called substitutes if an increase in the price of X leads to an increase in the consumption of Y, or a decrease in the price of X leads to a decrease in the consumption of Y. So we see that a decrease in the consumption of in the price of good X has led to a decrease in the consumption of Y, and therefore that tells us that the goods are substitutes. So this is another way that we can figure out if consumers view two goods as either complements or substitutes, depending on how their optimal consumption bundle changes when prices change in the market. So if goods X and Y are substitutes, a reduction in the price of X would lead the consumer to move from point A to point B, where less of Y is consumed than at point A. A second possibility is that goods X and Y are complements, and that happens if an increase in the price of good X leads to a decrease in the consumption of good Y. So the opposite happens as well if they're complements. If there's a decrease in the price of X, as we just saw, there's a decrease in the consumption of good Y. I'm sorry, an increase in the consumption of good Y. So again, it's the same definitions of substitutes and complements that we've come to know, but you can demonstrate that relationship graphically depending on the nature of the preferences which are embodied in the indifference curves. According to the preferences of this consumer, based on the curvature of these indifference curves, the consumer, as the price of X has gone up, will purchase more of X and less of Y, substituting away from Y to X, meaning that she views these goods as substitutes. Another thing we can examine is changes of income. So a change in income will also lead to a change in the consumption pattern of the consumers. Assume the consumer initially is at that equilibrium A. Now suppose the consumer's income increases from that initial amount M 0 to M1. So that shifts our budget line out, expanding the budget set, getting us to a higher indifference curve. Therefore, the optimal consumption bundle is going to be a B in this case. All right, as in the case of a price change, the exact location of the new equilibrium point will depend on consumer preferences. So recall that good X is a normal good if the increase in income leads to an increase in the consumption of that good, and a decrease in income leads to a decrease in the consumption of that good. Note in the figure that the consumption of both X and Y increased due to an increase in the consumer's income. So that tells us that both goods are normal goods. Recall that good X is an inferior good if an increase in income leads to a decrease in the consumption of good X, and a decrease in income leads to an increase in the consumption of good X. It's important to repeat that by calling the goods inferior, we do not imply that they are inherently of poor quality. It's a subjective thing. It's simply a term used to define products consumers purchase less of when their income goes up and vice versa. So this would be an example of a situation where you could have an inferior good, and you can see that the preferences are going, so this is like one indifference curve here, and this is another indifference curve here, and because of the curvature of them, that they're very steep, like that's going to get us to that sort of reaction when income changes of the consumer consuming less of one good, which will allow me just to highlight how we can demonstrate preferences differently by indifference curves, and if preferences are different, that you will get different results. In this case, you will be able to identify one of the goods as being inferior. So the figure depicts the effect of an increase in income for the case in which, in this way, actually good X is an inferior good. So X is considered an inferior good. So we have income that is going to increase. So I think this black line here is our original budget line. And our income increases, so we shift the budget line out. This is our initial optimal consumption bundle, A with a little bit of Y and a lot of X. Income has gone up, shifting the budget line out, and now the highest indifference curve this consumer can consume on is going to be 2 here. So the optimal consumption bundle, as a result of the increase, is going to be a B with a lot more Y, and in this case, a reduction in X. So as income went up, the quantity consumed of X went down. Therefore, the consumer views X as an inferior good. And again, like there's a lot of information that's embodied in the shape of the indifference curves, which, if specified differently, will specify different preferences. Since at point B, the consumer consumes more of Y than at point A, we know that Y is a normal good. However, note that at point B, less of good X is consumed than at point A, so we know that X is an inferior good. All right, so that's some information you can get from this model with some changes, but the most important information we can get is the breakdown of a price change into the substitution and the income effect. So we can combine our analysis of price and income changes to gain a better understanding of the effect of a price change on consumer behavior. So suppose the consumer is initially at that optimal consumption bundle A. Suppose the price of good X increases in this case. So the price of good X increases. What's going to happen to this intercept? Right, it's going to come in right towards the origin. That means the budget line will rotate in. So the budget line rotates in clockwise because the price of good X has now gone down. The market rate of substitution has now gone up, meaning that the exchange of X is now higher for Y because X costs more. So there's 2 things to notice about this change. First, since the budget set is smaller due to the price increase, the consumer will be worse off after the price increase. So again, if you think of income in real terms as like everything you can buy with your income, if the price of one thing goes up, then it shrinks the amount that you can buy of everything, right? So that's captured by the rotation of the budget line in, shrinking the opportunity set, the consumption set. Second, the increase in the price of good X leads to a budget line with a steeper slope, again reflecting a higher market rate of substitution between the two goods. So these two factors lead the consumer to move from that initial equilibrium A to the new equilibrium C. Now, it's useful to isolate the two effects of a price change to see how each effect individually alters consumption, the consumption choice. So in particular, ignore for a moment the fact that the price increase leads to a lower indifference curve. So we're going to ignore the fact that that price increase got us to that lower indifference curve, and we're going to say, well, what if the consumer can be compensated in terms of more income in order for the consumer to be as well off as they were before, and therefore be able to consume on the old indifference curve, have the same level of utility, even though there's a different market rate of substitution now. So suppose that after the price increase, the consumer is given enough income to achieve the budget line connecting, in this case, J and I. So the red budget line represents like this hypothetical income that the consumer would be given in order to be able to consume a consumption bundle that will make her as happy as she was before the price increase. So the budget line that we have here, this red one, has the same slope as the one that was rotated in because the market rate of substitution is the same there. We assume that the relative prices change. But again, we're imagining that the consumer can be given more income at that new market rate of substitution to be able to consume on the old indifference curve to be as happy as they were before. So given this budget line, the consumer will achieve equilibrium at point B, where less of good X is consumed than in the initial situation, point A. So the price has gone down, and if the consumer was given enough money, income, to be able to consume on that same indifference curve, she will substitute away from X to Y because the market rate of substitution has changed. And therefore, in order to be able to consume at that consumption bundle, the best she can do is this bundle versus that one. So that's the point where the marginal rate of substitution is now equal to the new market rate of substitution. So the movement from A to B is called the substitution effect. It's basically representing the amount of the decrease of good X that the consumer is now consuming due to substituting away from the good they were consuming to the other good because, again, the relative prices change because now X is more expensive in terms of Y. So that's changing how much she wants to consume of X and causing her to substitute away from X to Y to point B. So here, there's more of Y being consumed and less of X. So the substitution effect is the movement along a given indifference curve that results from a change in the relative price of the goods, holding real income constant. It reflects how a consumer will react to a different market rate of substitution. So in this case, the substitution effect can be measured as the difference between the amount of X she used to consume and the amount of X she does consume at this hypothetical new consumption bundle. So that's the substitution effect. Now, considering the equilibrium at point A again, we know that at point A, initially, the marginal utility per dollar spent was equivalent across both goods. The substitution effect from the price change reflects the increase in the relative price, resulting in, at that point, the marginal utility of good X, the per dollar spent, being less than the marginal utility per dollar spent on good Y. So a dollar spent on Y will give her a higher marginal utility than X, so she wants to consume more of Y than X, so she moves away from this consumption bundle towards this one. So again, this means that the marginal utility per dollar spent on good Y is now higher. Thus, it makes sense for the consumer that the consumer would substitute away from good X to good Y. All right, but in reality, we know the consumer does not actually face this red new budget line. It's a hypothetical. It's a way to identify the substitution effect. So let's go back to the income that we did give the consumer as a result of the price change. So we're back at FH here, and we're back at that consumption bundle C. So the shift in the budget line from where we were hypothetically to now where we are reflects a reduction in income. So the slope of the budget line, JH, that we had, the red one, and FH are identical. That means that the movement from B to C represents the income effect of a price change. So this analysis allows us to break down the change in the amount of X that's consumed due to an increase in the price of X into its substitution and its income effect. So the movement from A to B represents the substitution effect, the fact that now Y yields more marginal utility per dollar spent than X, so the consumer consumes more of X. The movement from more of Y rather than X, and the movement from consumption bundle B to C represents the result of the consumer feeling poorer overall from that increase in the price of X. Now, because of that, she has to consume less of everything. And so, therefore, from B to C, she consumes less of Y and less of X. And so, the difference between XM and X1 is the income effect of the change in the price, the increase in the price of the good. So we can use the model to deconstruct the effect of a price change into the income and substitution effect, which is a very powerful result. So again, the income effect is the movement from one indifference curve to another that results from the change in real income caused by a price change. The income effect is the difference between XM and X1. It reflects the fact that when price increases, the consumer's real income falls. Since good X is a normal good, the reduction in income leads to a reduction in the amount of good X, and the reduction in income also led to a reduction in the amount of Y, which also reflects the fact that it is a normal good as well. So to summarize, the total effect of a price increase, thus, is composed of a substitution and income effect. The substitution effect reflects a movement along an indifference curve, thus isolating the effect of a relative price change on consumption. The income effect results from the parallel shift in the budget line. Thus, it isolates the effect of reduced real income on consumption and is represented by the movement from point B to point C. All right. Happy Valentine's Day. So the total effect of a price increase is what we observe in the marketplace, and it's the movement from A to C. So that's what we observe, but with the model, we could deconstruct the change in someone's behavior, and therefore we can get information about the way markets are reacting to changes in price that give us more insights than just people are buying less when prices go up and people are buying more when, well, and vice versa. All right, let's do some applications of the indifference curve analysis, and then we'll call it a night. So the indifference curve analysis can be used to analyze a variety of situations. So you can analyze the choices of workers and managers. So we'll look at workers first, and then we'll look at managers, meaning like a worker's decision to either work or not work, and a manager's decision to prioritize, in the way that we applied here, profits over output and vice versa. So managers and workers are also individuals and therefore have preferences among the alternatives that confront them. Here we'll see that the indifference curve analysis for consumers can easily be modified to analyze the behavior of managers and other individuals employed by firms. In Chapter 6, we will see how these insights into the behavior of workers and managers can be used to construct efficient employment contracts. So first we'll look at the consumer and the trade-off they face between earning income or enjoying their lives, leisure. So most workers view both leisure and income as goods, right? They like more of both of them, and substitute between them at a diminishing rate along an indifference curve. So we can put income per day on the y-axis and leisure on the x-axis. A typical worker's indifference curve, where we measure the quantity of leisure consumed by an employee on the horizontal axis and the worker's income on the vertical axis, has the usual shape. Workers enjoy both income and leisure. To induce workers to give up leisure, firms must compensate them. So suppose a firm offers to pay a worker $10 for each hour of leisure the worker gives up, right? So that's their wage. In this instance, opportunities confront the worker or manager are given by our budget line. If the worker chooses to work 24-hour days, he or she consumes no leisure but earns $240. So the consumer has 24 hours to spend essentially. And if she spends it all on working, then she will make $240. Or she could not work at all and have 24 hours of leisure. So again, 10 by 24, $10 is her hourly wage. By 24 is $240 per day maximum she can earn, which is a vertical intercept of our budget line. If the worker chooses not to work, he or she consumes 24 hours of leisure but earns no income, which is a horizontal intercept. Worker behavior may be examined in much the same way we analyze consumer behavior. The worker attempts to achieve a higher indifference curve until he or she achieves one that is tangent, just touching the opportunity set. In this case, it's going to be at point E. So at point E, the consumer is making $80. So that means she is working 8 hours, and she therefore has 16 hours left over in the day for leisure, which is that amount there. So her optimal consumption bundle of work and leisure is represented by E, the most affordable consumption bundle that provides her the highest level of satisfaction. She is consuming that the bundle on the highest indifference curve. So that is the worker equilibrium. So again, there's 16 hours of leisure there and 8 hours of work. The worker consumes 16 hours of leisure and works 8 hours for a total of $80 in income. So that's just the general specification of how we can apply the model to the choice of a worker to either work or not work. Let's do a quick demonstration problem to kind of see how we can work it out. Suppose a worker is offered a wage of $5 per hour, let's say, plus a fixed payment of $40, which is a slight complication that we didn't see in the graph we just looked at. What is the equation for the worker's opportunity set in a given 24-hour day? So we need to figure out the budget set, essentially, for this consumer. So the income budget of a worker who consumes, let's say, so the variable here is going to be hours of leisure, which we represent by L. So the budget of a worker who consumes L hours of leisure in a 24-hour day is going to be given by, income again is represented by M. So she gets a $40 fixed payment plus the $5 wage times the amount she works, which is going to be equal to 24 minus L. Right? L is the amount of leisure that she works. So 24 hours minus that is going to give us the amount of hours she works. So therefore, that is going to be her income, her fixed payment plus her income. We can distribute this out multiplicatively. So we have 5 times 24 is 120 minus 5L there. 120 plus 40 is 160. So therefore, this is the equation for her budget set. What are the maximum total earnings a worker can earn in a day? What was that? 160 is correct, right? So if you put 0 hours for leisure, then you're going to have 160 left over, right? So that is the full income the consumer can earn in a day. All right. What is the minimum she can earn in a day? 40, right? Because 40 is that fixed payment. You can think of it as like an allowance. You can think of it as, some wealth that she has like just put aside. Maybe some government check, who knows? It's a fixed payment that she gets regardless of whether she works or not. So we got that 40. Another way to do it is to say, well, she's going to just have 24 hours of leisure, so L equals 24. So plugging that in will get us to 40 as well. What is the price to the worker of consuming an additional hour of leisure? $5, right? The opportunity cost of leisure, right? So in order to work, she has to give up leisure, an hour of leisure, which means she's going to earn an hour of wage, which is $5. Right? But to enjoy an hour of leisure, she gives up that $5. So that's her implicit cost, which is her opportunity cost. Opportunity cost is made up of implicit plus explicit costs. All right, an hour of leisure has an opportunity cost of $5 of foregone wages from not working that hour. This is the budget line plotted with that amount of fixed payment. It adds a kink to the budget line. Don't worry, you won't have to know this more complicated case, but this is just meant to show you that the model has flexibility and can be applied in different ways. So that is the budget line there. All right. Anyway, so that was the way that we can use the model to kind of study that that decision. And believe me, there are labor economists who use that a lot, and it explains a lot, and it helps with a lot of really in-depth analysis. You get a lot of really powerful results from it. But in the way that we showed it here, it's very simple. But again, it's about kind of just like getting you to kind of understand like the mechanics of the model, and then the more complicated applications, like these applications, like you don't really need to know them that well. Just kind of understand like the model can be applied in that way, given what you should understand about how the model works, which is what ultimately I want you to be able to do. I want you to be able to understand what that equilibrium means. What is the condition that is represented at that equilibrium? Why it's a stable equilibrium because of that condition. The margin utility per dollar spent on all goods is equivalent. It makes people want to just stay there versus go elsewhere, because elsewhere it's different. Just the basic mechanics. Most of the things that I explained to you, being able to kind of see, graphically what is meant by what is being shown to you, to be able to identify different things from it, that kind of thing. And definitely understand this application just in terms of intuitive, like what is happening and what I'm about to show you. This is something I would expect you to be able to understand. So it's been argued that many managers derive satisfaction from the underlying output and profits of their firm. So that is sort of the trade-off that managers face. Sometimes output and profits are kind of at odds. So the rationale is that higher profits and sales lead to a larger firm, and larger firms provide more perks like spacious offices, executive health clubs, corporate jets, and the like. Suppose a manager's preferences are such that he or she views the profits and output of the firm to be goods, so that more of each is preferred to less of each. The theory is not suggesting that it's optimal for you as a manager to have these types of preferences, but there may be instances in which your preferences are so aligned. In many sales jobs, individuals receive a bonus depending on the overall profitability of the firm. So under those situations, the managers may prefer to focus on profit versus output. The salesperson's ability to receive reimbursement for certain business-related expenses may depend on an individual's total output, is the opposite case. So there might be different incentives in place that will change the preferences of a manager. Additionally, perks such as a company plane, car, and so forth may be allocated to individuals based on a firm's output and profitability. So we've got three different panels here that represent three different possible scenarios that could result given what the incentives might be for a manager. So I would just expect you to understand what this means. I'm going to go through it in a second. So again, panels A, B, and C of the figure show the relation between profits and the output of a firm, and the curve labeled the firm's profits. So the firm's profits are these curves here that are essentially represent the budget constraint for the firm. And we'll talk about why profits are shaped like that later on in the course. So this curve goes from the origin to points C, A, and B, and represents the profits of the firm as a function of output. As output increases, profits increase, but then they start to decrease as you go further. This actually does, I remember we did explain this already in chapter 2 or chapter 3, where we identified the relationship between elasticity and revenues. How when demand was elastic, as you decrease price and increase output, revenues increase, which means that profits would increase. And then past the point where demand becomes inelastic, then lowering the price would actually lower revenues, right? So therefore you would have an increase in revenues up to a point, the point where demand is perfectly elastic, unit elastic, and then beyond that point where demand becomes inelastic, revenues start to decrease, which would then affect profits in the same way. So that's why we have that hump-shaped profit curve. When the firm sells no output, obviously profits are zero. As the firm expands output, profits increase, reaching a maximum at QM. So QM being the output that maximizes the profits. Same in all three. The only difference between the three is the shape of the indifference curves, representing different preferences for the manager. So given this relation between output and profits, a manager who views output and profits as goods will have indifference curves like we've been talking about in this course so far, in this lecture today. Just that rounded edge representing convex preferences, representing a diminishing marginal rate of substitution between output and profits. So she attempts to achieve a higher indifference curve until she eventually reaches that equilibrium point at point A. So with a manager that views both profits and output as goods, she will, her optimal point of production will be here. Note that that level of output, QU, is greater than the profit maximizing level of output, which is QM. So when the manager views both profits and output as goods, she produces more than the profit maximizing level of output. In contrast, when the manager's preferences depend solely on output, so if the manager's preferences depend solely on output, that means she's only interested in output, right? So there's some incentive built into her employment that causes her to just focus on output. And as a result of that, she does not care about what profits, and therefore her indifference curves are just going to be straight lines that are going to be constant along each level of output, meaning that her preferences are not changing as profits change. And so she wants to obviously be at the highest indifference curve, which is going to be the one furthest away from the origin. In this case, it's going to be indifference curve 2. So one example of such a situation occurs when the owner of a car dealership pays the manager solely based on the number of cars sold, right? So that creates that kind of environment where the manager is only interested in the amount of sales, output in this case, because that's the only thing that affects her income. Since the manager does not care about profits, his or her difference curves are vertical lines, and satisfaction increases as the lines move farther to the right. A manager with such preferences will attempt to obtain the indifference curve farther and farther to the right until indifference curve I2 is reached, getting us to that point there, where the manager is as far away as possible from the profit maximizing level of output. Again, in this instance, the manager produces more than the profit maximizing level of output, and certainly more than if she viewed both profits and output as goods. And then finally, you have the manager that cares only about profits and not about output. So her indifference lines are flat indifference curves at each level of profits that does not change with respect to the level of output, because again, she only cares about profits, so that's how you represent those preferences there. The manager's indifference curves are horizontal lines. The manager maximizes satisfaction at point C, which corresponds to QM, the profit maximizing level of output. In this instance, profits are greater and output is lower than in the other two cases. So an important issue for this firm's owners is to induce managers to care solely about the profits, so that the result is to maximize the underlying value of the firm. So using this kind of analysis, you can get to this conclusion that shows us that in order for a firm to maximize its profits, that the approach has to be to incentivize managers to care about profits, not about output. And so in order to do that, we'll talk about that in chapter 6, where you just kind of create an incentive structure where the income is linked to the profits of the firm, which then causes them to prioritize profits, which causes the firm to maximize its profits. Just kind of understand, like, the difference between this case, and this case graphically. Just understand what it means. All right, we're almost there, folks. All right, the relation between indifference curve analysis and demand curve. So how do we get from this model to our demand curve? So the indifference curve approach developed is the basis for the demand functions we've studied. So let's say the consumer has a budget line and consumes at the optimal consumption bundle, which again represents the most affordable and most preferred combination of goods X and Y. And we're going to get to the individual demand curve for this consumer by considering price changes. So initially the consumer is at point A, where income is fixed at M and prices are P0X and Py. We're going to consider a change in the price of good X. When the price of X falls, we know that the consumer is going to be able to buy more of X, which means that the budget line will rotate outwards, which will get the consumer to a higher indifference curve, which will represent a higher amount of good X that can be consumed. So initially, the consumer is here, consuming that amount of X. Over here, we've got our the XY plane represented by a market, where again you've got the price of the good on the Y-axis and the amount of the good on the X-axis. So the consumer consuming amount of X corresponds to this same amount of X at the price P naught X, which is embodied in the slope of our budget line, the relative price of the two goods, the market rate of substitution. When the price of good X falls to the lower level, indicated by PX1, the opportunity set expands and the consumer reaches a new equilibrium at point B, right? So the budget line pivots out, the consumer then moves to this optimal consumption bundle, the most affordable and most preferred consumption bundle, and that consumption bundle has a higher amount of good X. So at this now lower price, P1X, the consumer is now consuming X2. So we plot that point here. So there's our price lower than the initial price, corresponding to that higher amount of X that is being demanded, consumed by this consumer. So the relation between the price of good X and the quantity consumed of good X is the individual's demand curve for good X, right? We can connect the points and we can then have the demand curve for this individual consumer. And then we can get to market demand by aggregating demand. So you will usually, in your role as a manager, be interested in determining the total demand by all consumers of your firm's product. The information is summarized in the market demand curve, which is what we've been looking at in the demand supply framework model, the competitive market model that we looked at in chapter 2, and we extended to chapter 3. So the market demand curve is the horizontal summation of individual demand curves and indicates the total quantity all consumers in the market would purchase at each possible price. So let's say you have some consumer with some preferences that, as a result of changes in price, led to this demand curve. So this is some consumer A. And then we have some other consumer with some other preferences that led to a steeper demand curve, B. So they represent the individual demand curves of two hypothetical consumers, Mrs. A and Mrs. B. When the price is $60, Miss A buys 0 and Miss B buys 0. When the price, at the market level for $60, obviously both of them will buy 0. So at $60, it will be 0 for the market demand curve. At $40, Mrs. A is willing to buy 40 units, Mrs. B is willing to buy 20 units, and so at the market level, at $40, the consumers will collectively wind up buying 30 units at a price of $40. So you can do a horizontal summation across all prices of individual demand curves to get to the market demand curve from an individual's demand. So continuing what we just did for the price of $40 along all the prices, you would wind up with a curve that looks like that, which is the market demand curve. So that's how you get from the model that models the individual choices of a consumer based on their preferences, based on prices and income that they face in the market, to their individual demand curve, And then you can combine those individual demands into the market demand curve, and you can have all sorts of information about the market that you're interested in. And you're done. We're done for the day, folks. We're done 25 minutes early. It's my gift to you on this Valentine's Day. Hold on a second.